Hi, I'm out at the National Park Service in Kaloko-Honokōhau on the Big Island of Hawaii with the purpose of testing the Arrow Gold Plus with Esri field maps running on an iPad mini against survey control that was established back in 2006 with long occupation times and then updated several times since then. It's actually right on the head of this nut on this utility cabinet. For corrections, we'll be tapping into the National Park Service RTK base station a few kilometers away. There are actually 3 on the Big Island, 3 RTK bases run by the Park Service, and 5 in Hawaii total that are publicly available. So the question might be, why do we need to do this type of field testing? Well, there's 2 components. One is to test, obviously, the accuracy of the GNSS receiver itself and how well it's performing. But number 2, to make sure that the software is set up, in this case it's Esri Field Maps, is set up properly so we have the location profile set up and we're getting the accuracy that we think we should be getting. And so we can compare the data collected with this setup here against the coordinates of the survey mark here. And this is a good standard practice for folks because I've seen a lot of cases where people will go out and collect data using the wrong datum or the wrong coordinate system and then have to fix their data later on. It's better to have some kind of test mark that you can go out and occupy really quickly, either daily or weekly or perhaps monthly, to test out that your equipment configuration, your software configuration is proper and accurate. So in field maps, we have the survey monument loaded up into field maps. It's covered up by the position icon, but you can see if we tap on the current GNSS details, we can see the provider is Arrow Gold Plus. I've got the Hawaii RTK location profile, which uses the PA11 datum. And then of course you can see RTK fixed and 0.4 centimeters horizontal and 0.7 vertical, and with a pretty tight correction age of 1 to 2 seconds and lots of satellites. So to take a shot, I've got it set up to 5-second averaging. So I hit the plus button. You can see it's starting to average. I'm going to enter the ID of the monument, which is FFBW58. Hit done, tap on submit, and during that time it's taken 5 seconds of data. And remember, with field maps, it starts collecting data right when you hit the plus button. Now the internet's a little bit slow out here in the field, but you can see it stored it now. This is all the attribute information. We have the obviously lat long altitude, timestamp. Down towards the bottom there's average horizontal accuracy, average vertical accuracy, the number of positions to average, and the standard deviation. And we'll take 5-second occupation times over a number of different times and then compare it against the survey control. It's an Opus shared solution, so we know the accuracy of the control coordinates with a reasonable degree of confidence. I think a couple of centimeters X and Y. So where can you find survey monuments? Well, the Park Service has their own set of survey monuments that they have Opus shared solutions. But if you Google NGS Data Explorer, there's an entire database of survey marks throughout the US that you can access. And they all have certain 2D RMS values for horizontal and vertical that you can search for, because not all the control points or survey marks in the NGS database are appropriate for this kind of testing. You want to pick the high quality ones. So if you don't have a survey mark near your location, which is somewhat common, you can set up your own with the Arrow Gold and field maps. And so you can set up your equipment on a tripod, collect data for Opus, which is the online user positioning system run by the federal government. It's a free service. You collect data for at least 2 hours, static data, and then submit it to Opus, and they will return to you a coordinate with some accuracy statistics attached to it. And you can use that as your control, and you can set a PK nail in the ground or some existing monument like this one right here with just a nut head on a manhole cover or something along those lines that is permanent and not going to move. So in summary, this is a great way to test your workflows and your equipment setup to make sure it's conforming to the accuracy that you expect from the equipment. There's lots of public information available on survey monuments, RTK base stations, and EOS's technical support is standing by to help you answer all your questions and help you through this process. Signing off from Kona, Hawaii at at the National Park Service. Thanks for watching.